All right, welcome to part 4 in our series of connecting soil health in bigger deer. Part 4, we're going to look at some soil sample examples, and then we're going to talk about chemical versus biological. So this is a typical soil sample that most people that have sent in soil samples have seen and are used to seeing. And we're going to focus on a couple things on the typical soil sample that we're all used to seeing. Um, First of all, we'll talk a little bit about organic matter. So the soil organic matter it'll give you an insight into how productive your soil is actually going to be. The higher in organic matter content, the more productive the soil will be. The organic matter helps retain moisture, helps to make the soil porous, and allows things to move through the system. So generally, the better organic matters are above that 3, and you'll see that in the heavier grounds, sand grounds, you're like 1.5, kind of like we're seeing here. The next thing, soil pH. We talked kind of in detail about pH, scale of 0 to 14, 7 being neutral, above 7, and then below 7, you're either acidic or alkaline. And then you got some issues that you got to deal with in plant nutrient uptake being limited due to those. So there's ways that we can alter the pH. Some of them are fast, don't last a long time. Some of them are slower but last longer. The third thing that I'd like to look at is the cation exchange capacity, which will be listed as CEC on your soil test. And it indicates how well the plant or the soil can hold the plant nutrients. Clay ground is going to have a higher CEC than sand ground due to the things that we've already discussed. As far as surface area, the ability to have more negatively charged space to allow positively charged nutrients to be attracted and held in that section of the soil. So those are kind of the big 3, and then obviously we have our nutrients with our phosphorus and our potassium, zinc, manganese, boron, all that stuff is included in there also. So what I really want to kind of get through today is if you think about CEC, pH, and organic matter. These are important things, and I'm not saying that they're not important, but how I want you to view them is think about when you go to a doctor's office, what's the first thing that the doctor or the nurse has you do? They have you step on a scale and they get your height and they get your weight and they take your blood pressure. Those are the 3 things that happen right away. And part of the reason that they do that is because that is something that they can, over time, be able to see if there's any major fluctuations that have occurred. And that's similar to how I want you to view your pH, your organic matter, and your CEC. It's a 3-legged stool. It is the lead indicators of the overall health of the system, just like height, weight, BP would be the major indicators. If something really drastic has changed, or if you're moving the needle in a positive direction with your own health. So similarly, when you go to the doctor, if there's an underlying issue, what they'll do is they'll send out for a more intuitive test, whether it be a blood test or your analysis, whatever, to dig down and find out what is the actual root cause of the issues that we're seeing. And similarly to how we view it with our health, we can do this also through soil samples. So before we kind of get really deep into that, I wanted to show this. This is an experiment test that Sparks did in 2003, where he took soil from all over the world, different types of soils from all different areas of the world. And what he wanted to know was how much nutrients are in the soil. And what we can see by looking at what he found is they're in the range. If we look at some things that we're familiar with, nitrogen, the range was 200 to 5,000. So even in the poorest soils he could find, there were 200 units of nitrogen in that soil, all the way up to 5,000 nutrients. The median was 2,000. Now, none of us are spreading 2,000 units of nitrogen on our crops or our food plots. Similarly, you look at potassium, the medium's 14,000, and phosphorus 800. Again, we're not spreading that much, but why are we having to spread fertilizer, put fertilizer into a system when it's already there? And the key to that is most of this that's already in the soil isn't plant available. It hasn't been transformed into that form that the plant can actually use and uptake. So our goal is, instead of spending a ton of money every year on fertilizer and putting it into a system that already has those nutrients, we want to make the nutrients that are in our soil, we want to take part of them and make them available. That'll help cut down on our costs. So what we can do is we can take a step up in soil samples and do what's called a Haney test. With the Haney test, you still get your chemistry. You still get the stuff that you would get with a normal soil test that you're used to. So this is one that I had done on an area that I've been working with for 4 years now, just trying to get some of my sand ground more productive. So as you can see from this one, organic matter is at 3, which for my area is definitely improvement. My pH is 7.2 on this one. My cation exchange capacity is 9.2. For me, these numbers show that I'm moving the needle in the right direction. These are much improved numbers over what I was seeing in the past. But I'm still having problems getting things to grow. That's where the second part of this Haney test comes in, is he'll do what is an H3A soil extraction. And the soil extraction is going to give you, it's going to mimic the organic acids produced by living root plants, and then show you what is there and the nutrient availability in the root zone. So again, I have very high amounts of phosphorus, potassium, magnesium, calcium, sodium, alumina, all that. I have it. Everything is, as far as what's in my soil, looks really good. But as we move down and we look at the water soluble section, how much of all of this is actually usable? Very little, hardly any at all. And that is showing here on a piece of paper that it is locked up. It's locked up in the soil, unavailable to the plants. Then as we move down, the 1-day CO burst, this is when they take amount of soil and then they wet it and they measure the amount of CO2 that is released from the soil, from the microbes through the microbial respiration. This test is really dependent on the amount of carbon that is available in the soil and the form that that carbon is in. So if you look at this and we kind of go through, it's showing that I've got a light green CO2 burst, which means that I do have a lot of microbial life in the soil. It's not high, it's not optimum, but I have it there. Yet I'm still seeing that I'm lacking in the microbes being able to convert those nutrients that are locked up into um, usable minerals and nutrients for the plant. And when you put all this together, they give you a soil health calculation, which is 6.1. So the question here is, what is holding me back? What is causing me not to be able to release the nutrients that I'm getting or that I have in my soil to be able to be used by the plants with an okay, it's not great, it's not good, but it's okay amount of microorganisms in the soil. And this was actually kind of interesting because I took this information, and that was a question that I posed to a gentleman at the lab. And what he was able to share with me is that more than likely what's happening in my soil is, you have to remember that this is taking a bit of that soil that is dry, then they wet it, then they extract that CO2 burst out of. But because of the majority of my soil being sandy and my organic matter being okay but not good, because of the heat and not having the ground cover on the soil, my soil is heating up so early in the day that it's baking out the soil, killing the microorganisms, and we don't have a consistent cycle of activity going on. What's happening is the soil is laying dead and dormant. We get a rainstorm, it comes alive, it does the process, the factory starts working, but then as soon as the sun comes out and it dries out, the factory shuts down. So I have the nutrients, I have the microbiology. My missing thing that I'm having is to have a really good dense cover on that soil that's protecting that factory from shutting down and getting baked out by the heat and the sun due to the sandy types of soil that I have on my property. So that really, I mean, this is just adding more pieces to the puzzle for me to be able to understand what the challenges that I had here on my ground. I have the tools. I have all the tools that I need. I just need to keep that factory running all the time instead of after a rainstorm, the factory starts up, everything's churning, and it shuts back off until the next rainstorm. It's just a constant struggle that I'm going through. So the biology is a big thing, and we're going to go into this more in our next seminar. But when it does rain on my soil, what happens? So the biology wakes up and it starts doing its job. It starts working. What we need to understand is a single teaspoon of soil contains over 1 billion bacteria and about 120,000 fungi and 25,000 algae. These are our workforce. These are doing the work for us. These are the microorganisms that if we can balance out the ground cover, the healthy roots, the moisture and everything, these will do the work for us. And the biology will farm the soil, release those nutrients, and allow us to cut down on our fertilizer and a lot of the other expenses that we have out there. So farming for the soil versus farming for the plants creates more nutrient dense and healthy plants to feed animals, and this allows them to reach their maximum genetic expression. So just kind of a rundown there of the different type of soil samples and how we can dial it down even further to find the root causes of the things that are causing us issues. So next I just talked about having that microbiology to release those nutrients, but I think that it would be good to spend one seminar on actually talking about that process. So you guys understand when John or I are saying get the microbiology up and running so they can work for you, you understand what that means. So thank you for joining part 4. Part 5 coming up will be the soil food web.